But before we jump into that, a few words about myself. My name is Anton. I've been developing software for the past 15 years now. Joined Cosmos pretty early, back in 2016. Became one of the biggest contributors to Comet. Just to kind of know you better, who's here joined Cosmos back in 2018? 20? 22? 24? Okay, awesome. It's cool to see some familiar faces. Currently, I work at Informal, where we're doing a bunch of cool things, including obviously maintaining part of the Interchain stack and security audits. And also, we developed some new projects like cycles.money. If you want to learn more about this, come talk to me or one of my colleagues. What I'm going to talk about today. First, I'll briefly explain what Comet is for those who are new to the ecosystem. Then I'm going to talk about the current state of things, and I'll finish my talk with new and upcoming features. So what is Comet? If there are any web developers out there, maybe in the past, you'd probably know what Python's Django or Ruby on Rails are. Those are the frameworks for building web applications. And similarly, Comet is a framework for building blockchain applications. In a nutshell, it consists of three parts: consensus, peer-to-peer, and ABCI. Consensus is how nodes agree on the next block. Peer-to-peer is how they exchange data between each other. And ABCI is a special interface that separates the application from the other components. So you, for example, as an application developer, don't need to focus on peer-to-peer or consensus. You just focus on the application logic, and that's all. I have listed some of the methods here. For example, Comet calls checktext when it wants application to verify a transaction. It calls prepare proposal when it wants application to form the next block. It calls process proposal when it wants application to verify a block that it received from the network. And it calls finalize block when it wants application to commit the new state. And here I'm talking about some application. You need to understand that it can be any arbitrarily complex state machine like Cosmoverse, for example, which gives you smart contracts written in Rust programming language. In terms of positioning in the Interchain stack, it's right there in the bottom, so you don't normally interact with it. And it's pretty old. Yeah, I've dug up this photo back from June 2016, where Ethan, one of the Cosmos co-founders, talks about Comet, or Tenement, how it was called before. Shout out to the oldies who remember. And this is actually one of the reasons why people choose Comet, because it's been in production since 2019. It's battle tested, it passed multiple security audits, it was verified by Jepsen. It gives you instant finality, it can process. It's relatively fast, I would say. It can process up to 500 transactions per second, according to our latest report. In a network with 200 nodes, not globally distributed though. And it's also developer friendly because it's written in Go and has a ABCI. Okay, this number is completely made up, but I'll still say it, that 99% of the Cosmos projects are using Comet, even if they don't know about it. So if they're using Cosmos SDK, they're using Comet. Comet BFT is also used outside of the Cosmos network, even outside of the Web3 sphere exact details, unfortunately, now, but we're starting to see some really exciting use cases. With that, let's talk about the current state of things. We've recently released a couple of really cool features. One of them is PBTS, proposer-based timestamps. It replaces the old algorithm. Blocks time is now more accurate, which is very good for time-sensitive applications. And it also paves the way for signature aggregation. Another cool feature is ABCI 2.0, which allowed Cosmos SDK to implement optimistic block execution. But more importantly, you can now attach arbitrary data to votes, and then this data could be used by the next block proposer, and this unlocks some really powerful use cases. For example, decentralized price oracles, or threshold decryption for transaction privacy, or cross-chain coordination. We've also worked on some other things, obviously, like performance optimization in collaboration with Osmosis team. Bandwidth reduction, we've also added BLS curve recently. We've streamlined our release process and doing releases faster and faster now. We now have a release support policy that we would like to stick to, ideally. If you're interested, then go to our GitHub and check it out. Unfortunately, some of the teams recently experienced spam attacks. That's why we've wrote a guide which can help them mitigate some of it. But the general tagline is that they should upgrade to the latest version if they want all the improvements and bug fixes. And in the near future, hopefully in V1.1, they will be able to use mempool lanes. And this is our most recent feature. It is available in the experimental branch. So what are the mempool lanes? Before, the mempool was just a single list of transactions. Now it's more like a map of sublists, whereby each list can have a different priority application defined. And hopefully you could see how this helps with spam protection, because you can have transactions with higher priority that will be disseminated faster in the network and will be included in the following blocks, like next block or the block after, faster than the transactions with lower priority. We're also working on Quick. TCP has been our default go-to transport protocol. It does the job, but Quick has some really neat features that we would like to accommodate. For example, it has built-in streams, so no need for custom out-of-protocol multiplexing. It has zero-TZ handshake, no head-of-line blocking. It will also remove the need for custom encryption that we currently have because it has TLS. We're also exploring other ideas like DOG, not the literal DOG, dynamic optimal graph. It is an algorithm developed by my colleague Hernan, which extends the base flood algorithm with a mechanism to eliminate cycles. And we've got pretty damn impressive results for you to see, preliminary results. In a 200-node network and transaction workload close to saturation, we've achieved a bandwidth reduction of 75%. As you can see, the node starts at 3.2 gigabytes per second, and then it gradually declines to 1.3 gigabytes per second as it kind of eliminates the cycles in a transactions paths, like in a network. Well, of course, we're exploring other ideas like BLS signature aggregation, soft updates, soft upgrades, meaning no hard forks, pre-confirmations, pluggable crypto, and others. So if Comet V1 looks like this, I would imagine Comet V2 look more like this, hopefully. What it will mean in terms of features, I'd say Comet V2 will be much better management, and that means network, memory, disk. It will be much stable under high load of transactions. And also, yeah, just generally much better. Just to recap what we've talked about so far, Comet BFT is battle-tested, fast, and developer-friendly consensus engine. Informal teams and teams that are using Comet BFT are constantly contributing and innovating on this product. If you want to help or you want to join, like come to Hackmos and also come to Comet BFT workshop tomorrow at 2:30, which will be run by my colleague Daniel. And yeah, like if you just need help upgrading or modifying Comet, please reach out. We would love to help. And we also